This lesson deals with powers and roots of complex numbers. This will be dealt with in two videos. This is the first of the two videos, and we'll be dealing with powers of the complex numbers. So let's begin by trying to find the 2 cis 30 degrees squared. 2 cis 30 degrees is complex polar form, and that's what we're going to be dealing with. So 2 cis 30 squared is simply 2 cis 30 degrees times 2 cis 30 degrees. And when we do that, we get 2 times 2. We've done this in a previous lesson where we multiplied two complex polar numbers together. We multiply the coefficients, so we get 4 cis, and then we add the angles together. 30 degrees plus 30 degrees is 60 degrees. So now, what if I want 2 cis 30 degrees to the third power? Simply change. So the power is now 3. Well, that just means 2 cis 30 times 2 cis 30 times 2 cis 30. But I already know what 2 cis 30 times 2 cis 30 is. I have that as 4 cis 30. So I'm going to write this as 2 cis 30 squared times 2 cis 30 to the first. And what we get is, first of all, we have to substitute. 2 cis 30 squared, we know from above, is 4 cis 60 degrees. And we're going to multiply that by 2 cis 30. And when we do that, we've now got a situation where we just have two complex polar numbers again. So 4 times 2 gets us the coefficient. Cis 60 plus 30 gives us 90 degrees. Okay, so now let's try to the fourth power. So if I want 2 cis 30 to the fourth, then that's simply going to be, well, I guess we can write this one of two ways. We could either write it as 2 cis 30 squared times 2 cis 30 squared. That'll get us the fourth power. Or we can write it as 2 cis 30 to the third times 2 cis 30 to the first. Again, that'll get us to the fourth power. We have substitutions for both of those, so it doesn't matter how you want to think of it. For consistency's sake, I'm going to write it as the previous power and then just have another factor of 2 cis 30 added onto that, as multiplied to that. So I'm going to rewrite this as 2 cis 30 degrees to the times 2 cis 30 to the first. And now we have the substitution. 2 cis 30 to the third is 8 cis 90 degrees. Put that in parentheses. Multiply that by 2 cis 30 to the first. And again, we put ourselves in a situation where we're just multiplying two complex polar numbers. 8 times 2 is 16. Cis, now we have 90 degrees plus 30 degrees is 120 degrees. So what if I now wanted to expand that and talk about 2 cis 30 to the fifth? So hopefully at this point we can see that there's a pattern emerging for us. If I now want to talk about 2 cis 30 to the fifth power, maybe we can figure out a pattern here. So let's look at what we have. So in this we just multiplied 2 by 2, we got 4. Here we had 4 times 2 to get 8, and 8 times 2 to get 16. But if you look at those numbers, 4 is the same thing as 2 squared, and 8 is 2 to the third power, and 16 is 2 to the fourth power. So that seems to be a pattern there for the coefficient. And if you look at the angles, here we had 30 plus 30, so this is two 30-degree angles. And here we had 60 plus 30, well this is two 30s, and that's one 30, so 90 gets us three 30-degree angles. Then we had 90 plus 30, we had three 30-degree angles here in the 8 cis 90, and we had one 30-degree angle there. So that's four 30-degree angles there. And if we look at the power, again, 4 times 30 degrees is 120, 3 times 30 degrees is 90, and 2 times 30 degrees is 60. So if we had to make a conjecture, we would hopefully would say 2 cis 30 degrees is 2 raised to the 5th power cis, and then the angle would be 5 times 30 degrees. Five times 30 degrees. Which gets us 32 cis 150 degrees. And does that follow our pattern? So we can see indeed that it does. 32 is 2 to the 5th. That follows our pattern of 2 to the power. 150 degrees follows our pattern. If we wrote 2 cis 30 degrees to the 5th as 2 cis 30 degrees to the 4th times 2 cis 30 degrees to the 1st, we would replace the 4th with 120, and then we would add 30 to that. So with the substitution, we would have got 150, and with our noticing the pattern, we also get 150. So now I can generalize this. If I wanted 2 cis 30 degrees to the nth power, well, I would just take 2 to the nth power cis n times 30 degrees. Or I could further generalize. We take the general form of a complex polar, and that is r cis theta. And if we want to raise that to the nth power, we get r raised to the nth power cis n times theta. And this is called DeMoivre's theorem. And DeMoivre's theorem states that anytime you have complex polar raised to the nth power, you take coefficient raised to the power cis the angle times the power. Okay? Now, for our purposes in this lesson, we were talking about n as integers, 2, 3, 4, 5, etc. However, it turns out that n can be fractions as well. And if we wanted to take the square root of r cis theta, so if I wanted to find the square root of r cis theta, that would be the same thing as r cis theta raised to the 1/2 power. And in the next lesson, in the second part of this video, we're going to deal with raising complex polars to fractional powers to get us roots.